Welcome to the math record. In the last video, I covered the derivatives of inverse sine and inverse cosine. Today, I'll be going over the derivative of inverse tangent and inverse cotangent. So let's start with tangent. So we have tangent, inverse tangent. So I'm going to do the same procedure what I did last time. That's equal to x. Taking the derivative of both sides. So the derivative of tangent is secant squared. And then keep whatever's inside the same. So inverse tan. Since it's a function inside of a function, we had to chain it. So the derivative of our inverse tan, which is what we're looking for. And then derivative of x is 1. So that means the derivative of our inverse tangent is equal to 1 divided by secant squared of tangent of negative 1. I mean secant squared of our inverse tangent composed inside. So drawing our picture, we have theta. So tangent is opposite over adjacent. So that means it's x divided by 1. So x divided by 1 gives us our x. So that means using Pythagorean theorem, x squared plus 1 squared is just x squared plus 1, and then take the square root. So that's our hypotenuse. So secant is opposite is is adjacent divided by our hypotenuse. I mean our hypotenuse divided by adjacent. So hypotenuse divided by adjacent. So that's just gonna simplify to square root x squared plus 1. So we're not looking for secant though, we're looking for secant squared. So we gotta square this. So just square this would be x squared plus 1. So that means our tangent, all it does is simplify down to 1 divided by x squared plus 1. Okay, that seems pretty simple now. Now we're going to do the same thing for tangent. I mean cotangent. Save that for now. So cotangent of inverse cotangent, sorry about that, that's equal to x. Now the derivative of cotangent, as we did before, is negative cosecant squared. And then keep whatever's inside the same, so inverse cotangent. So we have a function inside of a function, so we do the chain rule. So inverse cotangent of x derivative is equal to derivative of x, which is 1. So that means the derivative of our inverse cotangent is what we're looking for, is 1 divided by negative cosecant squared of cotangent, our inverse cotangent of x composed inside. So drawing our picture, right triangle, theta. So cotangent is actually adjacent and over opposite, so it's just the flip of tangent. So that means it's x divided by 1. So x on the adjacent and the 1 on the opposite. So then our hypotenuse is staying the same as usual. So x squared plus 1, square root. Cosecant is hypotenuse, so square root x squared plus 1. Okay, that looks bad. X squared plus 1 divided by the opposite, which is 1. So hypotenuse over the opposite is cosecant. So we have, but we're not looking for that though. We're looking for the square. So that gives us square, this simplifies to x squared plus 1. So the square of this is going to be x squared plus 1. But this is negative, so let's just move the negative to the top. So 1 times negative equals negative 1 over leftover is x squared plus 1. So it has a similar idea of how sine and inverse cosine worked. One is positive and one is negative. So let's look at these. So looking at tangent and cotangent, One is positive and one is negative, except instead of square root um, 1 minus x squared, we have x squared plus 1 on the bottom instead this time. Okay, so let's end it off with an example. So f of x is equal to 5. Let's say, let's work with tangent. So inverse tangent, and let's say 2x plus 1. So this might seem complicated since we're only working with tangent, but as we do, if we have a function side, we chain it. So the derivative of x, this is a scalar, so we don't have to worry about it. So 5. The derivative of tan is 1 divided by x squared plus 1. Our x this time is 2x plus 1, so let's substitute that in. So it's a square and then plus 1. Now we have to chain this, so we have to find the derivative of this. So the derivative of 2x plus 1, derivative of 2x is 2, and derivative of 1 is 0. So 2 plus 0 is 2, so we just multiply by 2. And let's say we want to find the derivative at, let's say x is equal to 3. Okay, so plugging that in, 5 times 2 is 10. And then 3 times 2 is 6. 6 plus 1 is 7. 7 squared is 49. 49 plus 1 is 50. So that means the derivative is 1 over 5, which basically means the slope of f of x at x equals 3 is 1 over 5. And that's basically it. Well, thanks for watching, and in the next video, I'll cover the derivative of the inverse secant and inverse cosecant. Thanks for watching.